Hey everyone, remember when we were talking about histograms and those fancy PDF things, that is probability density function things, I mentioned that histogram give you a general idea of the data spread. But there is a way to get a smoother picture, like transforming those rough bars into a beautiful curve like this. This magic is called kernel density estimation. This is how the histogram looks like. Now, from this histogram, I can compute my PDF. PDF, that is probability density function. How I can compute my PDF? By smoothing. SMOOTHING, called smoothing. So if I can smooth this histogram, I will get this PDF. This is my PDF. This represents PDF. Fine. So by smoothing this histogram, I am getting this PDF. Okay, but we haven't yet discussed how exactly it is done. So it is done using something called kernel density estimation. And here we are trying to understand how to construct a PDF from histogram. And for that we will use our bell-shaped curve. Here you can see a bell-shaped curve that we just learned while we were understanding about Gaussian distribution. Let us assume I have 6 observations. 1, 2, 3, 4, this 5 and 6. And this is how my histogram looks like. Fine. In this region, there are more points. In this region, there are fewer points. And in this region, there are also fewer points than this region. And in this region, there are no points at all. So for this distribution of points, this is how my probability density function looks like. You will notice that this is basically, what is this? This is basically a smooth reform of this histogram, except that we don't go to 0 here. We are not reaching 0 here, as in this case. Fine. The way it is constructed is basically building something called kernels. Fine. So we will understand this. The way it works is, let's say, as follows. So let's take each of my points here. So this is my first point, this is my second point, this is my third point, this is my fourth point, this is my fifth, and this is sixth point. Fine. So let's take this sixth point here. I am taking this sixth point here. So by taking this sixth point, I will construct a simple kernel, also called this Gaussian kernel, by taking the center of this sixth point. So around this sixth point, I have constructed this Gaussian kernel. This is called Gaussian, let me write it, Gaussian kernel. Fine. Here my bell-shaped curve, this bell-shaped curve is centered around my sixth point. Similarly, for my fifth point here, let's construct a Gaussian kernel centered around my fifth point. So here I can construct it like this. So this is the Gaussian kernel. This is my Gaussian kernel centered around my fifth point. This fifth point. Fine. And I have done the same thing with my fourth point, and so on and so forth. Now what I do is, at any point x here, let's take this point, let's take this point as x. So I am taking any point x here and I sum up the values. So in this case, what I will do is, I will sum up the values corresponding to x. So how many of my kernels do I have here? I have 3 kernels. You can see this is my first kernel, this is my second kernel, and this is my third kernel. And if I take this value, and this value, and I will sum up all 3 of them, I will get the height of my PDF using kernel density estimation. So I suppose this is the height of my PDF I will get after I will sum up these three values. I will get this height, which is the height of my PDF. This is called constructing PDF using kernel density estimation. Similarly, let's take some other point. I am taking, let's say another point here at x. So what I will get? Let's understand this. Similarly, at this point x, I want to find what is the height of a point here. So what all kernels do I have? I have this kernel with this height. I have this kernel with this height. I have this kernel with this height. I have this kernel with this height, and I have this kernel with this height. If I sum up all the height of all these kernels, I will get height somewhere around here. Let's say I am getting a point here, which means that my total height is going to be this much. This much is the total height after summing the height of all these kernels. After summing the height of all these kernels, I am getting a total height of here. Fine. So my total height will be this. My total height will be this height plus this height plus this height plus this height plus this height, and which will be finally this is my height, which is here. Correct. So this is called kernel density estimation. So this thing is called kernel density estimation. In short form, it is also written as KDE, or kernel density estimation. Same thing I have done here also. Here in this case x, and same thing I have done here also. So this is a kernel density estimation wherein I am drawing Gaussian kernels here. Now the next question is, the mean is around this point, around each one of my observations. Now what about variance? So let's talk about variance. So what about variance? Variance. Fine. The variance is called bandwidth. So this is basically my variance here. And this variance in kernel density estimation is basically called bandwidth. ADTH. So if you remember, when we learned about the histograms in exploratory data analysis, if some of you want to see, I will attach the link of my playlist in the description. We said that if you decrease the window size or if you increase the number of bins, the plot becomes very, very jagged. It will be something like this. Just remember that example that we saw, that as the number of bins increases, my PDF becomes very jagged. Similar properties apply for bandwidth. So why this is intuitively right? Let's say if there are more points in the neighborhood, so let us assume in this area, around this point, there are two other points, this point and this point, which means corresponding to this point, you will find a lot of densities. You will find a lot of densities corresponding to this middle point. Now, for example, you will find the kernel density of this point itself. Since these 2 points are in the proximity of my points here, I find a very high value of my Gaussian kernels here, because these 2 points are in the proximity of my this point here. That's why I find a very high value of my Gaussian kernels here. Now all 3 of them will add up to create a very, very large value. So if the points are crowded here, or if there is a high density of points here, my height will be more. As you can see, my height will be something like here. So if points are crowded here, or if there is a high density of points here, my height will be more. This is one way of smoothing. This is called kernel density estimation using Gaussian kernels. This is this small curve that we are drawing centering this point. These are called Gaussian kernels. Fine. Now, I told you about variance and how it impacts. The variance in this case is basically my bandwidth. Now, let's see something else. So, let us discuss a very nice concept here. Each of these vertical small blue lines here is my observation. So, let us assume this gray line here is my actual PDF. This is my actual PDF, probability density function. If I choose my kernels which are very wide, my PDF will look like my this green line. And if I choose kernels which are very narrow, like this red curve, I will get a line like my this red line here, which is again very jagged, just like our histograms when we had a lot of bins. So this red curve has a small bandwidth, fine, and this has a very large bandwidth. This green curve has a very large bandwidth. Fine. As you change your bandwidth, you will get a more smoother curve like your black curve. This black curve is a nice approximation of my actual PDF, which is a gray curve. As you change your bandwidth, you will get a more smoother curve like this black curve here. So this black curve is a nice approximation of my actual PDF, which is my gray curve here. So this black curve has a medium bandwidth. I can say this black curve has a medium bandwidth. So in a lot of libraries like Seaborn, there are nice heuristics, or you can say nice hacks on how to find the right bandwidth. So intuitively what they do is they choose a very small bandwidth to start with, and they measure how much jagged is this line, and they keep increasing the bandwidth till the time the line becomes smooth enough but not too flattened out. This is the idea of kernel density estimation using Gaussian kernels. Hope you have got the clarity of kernel density estimation using Gaussian kernels. So if you really like my videos, keep subscribing my channel and don't forget to put comments. Whatever doubts you will have in the comment section of the video, I will keep on doing the good work for all of you. Thanks. Keep learning, keep smiling. See you in the next session, where we will study sampling distribution.